Adam. For today, our group will present about forensic chemistry. Forensic chemistry is the application of chemistry to criminal investigations. It involves analyzing substances or materials found at crime scenes to help identify evidence and solve crimes. Forensic chemists use various scientific techniques and tools to examine evidence such as drug and toxic substance by identifying illegal drugs, poisons, or alcohol in biological samples. Secondly, explosive and residues by analyzing materials to determine the presence of explosives or gunpowder. Thirdly, trace evidence by examining small samples of substances like paint, glass, or fibers. Fourthly, chemical profiling by determining the origin or composition of materials like inks, plastics, or metals. The results provided by forensic chemists play a critical role in criminal justice, helping to confirm or refute hypotheses about how a crime occurred.
Have you ever wondered how scientists can identify people from just a tiny sample like a drop of blood or a hair strand? That's what DNA profiling does. It's used all over the world to solve crimes, find missing people, and even track family histories. Let's dive into how this powerful tool works and the chemistry behind it. There are three roles of DNA profiling. First, identifying suspects. DNA from evidence like blood, saliva, or hair can be matched to a suspect to confirm their involvement to a crime. Second is proving relationship. DNA profiling is used in paternity tests and to establish family relationship. Third is identifying remains. In disaster sites or old remains, DNA helps identify unknown individuals. For chemical bases, there are 5 steps. For first one, DNA structure. DNA is made of negatively charged molecules called nucleotides. The phosphate group gives DNA its negative charge, which is important for separation methods. Second is DNA extraction. Detergents break down open cell and alcohol is added to make the DNA clump together because DNA is insoluble in alcohol. Third is PCR, which is amplification. Heat separates DNA strands and an enzyme pulls new strands using complementary paths, pairing A with T, G with C. Gel electrophoresis, which is separation. DNA is placed in a gel and electricity moves it. The negative charge of DNA makes it move towards the positive side. 5 is STR, analysis. Fluorescent dyes bind to specific DNA regions and glow under a laser, helping scientists see patterns clearly.
Today we will explore the fascinating chemistry behind three chemistry forensic techniques, which is fingerprint analysis, blood detection, and drug testing. These methods are grounded in chemical principles that make them both reliable and precise. Firstly, fingerprint analysis. Fingerprint analysis are made up of sweats, oil, and organic compounds such as amino acid, fatty acid, and salt. Chemical techniques are designed to react with this component to visualize latent prints. As an example, silver nitrate reacts with chloride ion in sweat to produce silver chloride, which darkens upon exposure to UV light. Next, blood detections. Blood contains hemoglobin, a protein with iron at its core, which play a key role in detections. For example, hematase method. This method uses antibodies to detect human hemoglobin. And lastly, drug testing. Drug testing relies on chemical reactions and advanced instrumentations to identify and quantify compounds in biological samples. For example, immunoassays. This method uses antigen-antibody reaction to screen for specific drug classes. So, in conclusions, in fingerprint analysis, blood detection, and drug testing, chemistry enables the visualization, identification, and quantification of forensics evidence. These methods highlight the importance of chemical science in solving real-world problems.
Chromatography is an important biophysical technique that enables the separation between the mixture and a component. It helps us identify a component inside a mixture for a qualitative and quantitative analysis. This allows forensic to gather the component that may help investigators in giving evidence that may help them, such as blood sample inside a mixture. Other than that, it can also be used in identifying poison inside food that can cause the death. Next, spectrometry. Spectrometry is the measurement of interaction between light and matter. This causes a reaction that can be measured by radiation intensity and wavelength. A microscopic light source analyzer is shone onto a sample such as hair and paints that are too small to analyze with the naked eye. Will then be received by a receiver inside a computer and translated onto a computer screen. This allows investigators to see the sample in more detail than the naked eye.
And the final point, the impact and benefits of chemistry in our lives. Chemistry plays a crucial role in shaping modern society. Beyond forensic application, it has revolutionized medicine, agriculture, energy, and material science. The knowledge gained through chemistry has improved public health, provided clean drinking water, and led to life-saving drugs. In forensic chemistry specifically, it ensures justice by solving crimes and exonerating the innocent. Its benefits extend to creating safer communities and fostering technological advancement, highlighting its indispensable role in our daily lives. In conclusion, forensic chemistry stands at the crossroads of science and justice, leveraging tools like fingerprint analysis, blood detection, drug testing, chromatography, spectrometry, and DNA profiling. It uncovers the truth hidden in evidence. The scientific advancement not only solve crimes, but also ensure a more equitable society. Thank you.